This is a solution for number 20 from page 256 from Introductory Analysis by Dolciani et al. A V-shaped trough is 8 feet long, 3 feet wide, and 2 feet deep. Water is flowing into the trough at the rate of 5 cubic feet per minute. How fast is the depth of the water increasing as it is just about to overflow? A figure is conveniently provided. Yay, but we want to sketch it up a bit anyway. Although we're talking about the moment just as it's about to overflow, it's important that we actually pick some generic moment because we want to figure out the time changes, and if we pick a particular moment, we'll have frozen those out. So we're going to pick some generic moment when the height of the water is some distance little h. And we're talking about this much water, and that's supposed to be artistic. We could fill in the whole rest of the water like that. And we want to figure out what is the h dt at the moment that it's about to overflow. That is when h happens to be 2. Now, we were given dv dt, and we know that because we have cubic feet per minute. So we have dv dt, and that's given to be 5. What we'll need to do is connect v to h so we can take our time derivative. For a solid that's made of a cross-section smeared out along some length, the volume we get is just the area times that length. So for us, the length is going to be this, but the area we care about is going to be the triangle of water that's already filled, which will have height h and a base b. We can see that that triangle is similar to the overall triangle here in yellow. And what we end up with that, of course, is that the base is to the height as 3 is to 2. Or our base is 3/2 our height. The area of a triangle is 1/2 the base times the height, and for our volume then we'll end up with multiplying by that length, L. So for us all told, we can be able to put in and say 1/2 times 3/2 h times h times L, or 3L over 4 times h squared. To recap, our volume is 3/4 L times h squared, and L is a constant which I can later put in, or put in now, as 8. I'm going to leave it as it is. And what we wanted was dv dt, which is going to be a chain rule of dv dh times dh dt. And looking at this up here, dv dh is 3/4 times L times 2h. So we have something like this. But we were given that dv dt is 5. And we're given that the height is 2. So we have everything but the thing we want, dh dt. And so we can just solve for it by bringing the 24 to the other side and finding that dh dt is 5/24, and it will be in feet per minute.